Angular community right now. So the thing that bothers me, we as the Angular community have figured out this thing with race conditions. We had it. And then signals appeared, and we were like, nah. So what I want to do in this talk is share with you my feelings on signals, what to do, what not to do, and when to use observables. And what I want to particularly highlight is not this. 1 second. OK. That is working great. Awesome. Hello. OK, there we go. So I started my career with AngularJS. Actually, I did before a little bit of jQuery. And I wrote janky shade code. I did. Everyone does. The thing that bothers me, we had the thing called Ajax, and I wrote a bunch of race conditions. I have to admit that. And as I said, we as an Angular community had it figured out. But we decide now, and there are a bunch of blog posts out there recommending patterns, introducing race conditions to your applications. And with this talk, what I want to do is show you ways to prevent this. That is working so flawlessly. Cool, and great. So there's a picture here of my face, as you see. Sweet. I do have, cool. So my name is Jan-Niklas Wortmann. I am Jennifer Wardella's husband. I'm also developer advocate at JetBrains. I'm a member of the RxJS core team. So I feel like I'm allowed to have opinions on this topic. I am an Angular GDE, and as you maybe have seen before, I'm also on the Angular Plus show podcast thingy. So I want to talk about reactive primitives, just to set the stage properly. And talking about reactive primitives, I'm German. We like compound words. So what I do is I split things up. And if we look at the thing with reactive, reactive basically just means I want to propagate some change. I want to inform you something happened. And ideally, I want to react to that in some way. Primitive, on the other hand, I learned by looking this up, is apparently a pre-Renaissance painter. I didn't know that. But in this context, what we're talking about, it's actually a fundamental data type. Usually, when we talk about primitives, this means Boolean, string, number, those kind of things. In the case of signals, though, it also means we have a first-class support by our framework, by our language, for those kind of things. So let's bring this to the context of signals and observables. Signals are, just to set the stage properly, that we're always talking about the same things, signals are always synchronous. Always. Their API is fairly imperative, depending on how you like it. And now getting a little bit more technically, they have a publicly exposed producer. Sounds super fancy. I came up with that. What does this mean? With signals, what you're doing is you have a value somewhere and you say signal.set value. That value comes from somewhere. And that is what I mean with the value was produced publicly somewhere. Observables, on the other hand, a little bit different. Observables might be synchronous, might be asynchronous. Ideally, you shouldn't care, but in the end, you do have to care to some extent. Their API is a little bit more declarative. It's pretty declarative. But the thing that is important here is that the value production is hidden inside the producer. What does that mean? So if you might know the interval operator. It basically, once you call subscribe, starts a set interval under the hood. For a signal, what you would do is you say set interval, and then you take the value and say signal.set interval value. So that's the difference. Let's have a look closer at that. And this wouldn't be a talk about RxJS and signals and stuff if I wouldn't be here working with marble diagrams. That's what we do. And if my thing maybe now works, I would be in the position to draw something. Let's see. I'm not super optimistic that it works, but maybe. So let's see. It's not working. No, it's red. Awesome. I love when things just work flawlessly. Where did, okay. I know what happened. Give me a second. That's very important for the talk. You should make notes of this. Start your dev server apparently helps. I don't know who came up with this, but who would have guessed? I don't know. And Wi-Fi. Wi-Fi also helps. Come on, you can do it. How do you enjoy the conference so far? Having a good time? Yeah, me too. It does. Give me it. Really?
You do have a hardline in here connected to your laptop.
Okay.
So,
is it?
yeah, it's this right here. It's connected.
I don't have internet now. Maybe, maybe. No. Have you tried to turn it off and on again? Yes. Yes. How much time do I have? Plenty of time. Plenty. Okay. Come on. I'm absolutely not stressed. Yeah, I have plenty of time. Okay. Ha! Easy. Easy peasy. Okay, so this wouldn't be a talk about RxJS and signals if I wouldn't draw a marble diagram. Who knows marble diagrams? So basically, they are a way to represent an observable. And an observable, as I said, is synchronous or asynchronous, so there is a time factor involved. And this is represented by this very straight line. And this time might emit some values, like this beautifully drawn 1. And there might be another value coming eventually, 2, 3, that is a 3, and 4. Is the font size big enough? The thing you now do, what is it? That's going to be fine. The thing you now do with observables, usually you compose them. So what you do is you apply a fancy operator, something like, sorry for my handwriting again, something like filter. And in this example, we're filtering out all the odd values, right? So basically how this works is once you subscribe to this observable, then returned one by filter, this is subscribing to those values to get all the values, and then checking with the filter, is it in, what did I say, odd? I said odd. 1 is odd, so yes, we get a 1. 2 is not odd, so we don't get anything. 3 is odd again. 4 is not, so we don't get anything. This is basically how observables work. For signals, this is a little different, because signals are intended for rendering. So what you need to, you don't want to render the same value twice. Doesn't make sense. It's already rendered, so why should I render something again? So if we're looking at a signal, and with a similar scenario, for instance, an interval, so we have an interval signal that might emit the same thing, 1, 2, 3, and then in a computed statement we would check, is it an odd? Odd. It's an odd value. And this is represented by this triangle is odd. So what we would now do, basically applying the same logic. We would check, is it odd? Cool. And then return that. Well, signals behave fundamentally different. If we now have a value emission twice, this is a 1. Let me clean this up a little bit. There was an eraser. There it is. So if we have something like a very straight line, and we would emit 1 again, what would happen, our is odd would check, we would get 1, 1, and 1, 3. We wouldn't get that additional 1, because we already rendered that. And that is great for rendering purposes. This is not great if we're talking about general purpose RxJS stuff where you might want to apply business logic. Because in here, if we would fill the same thing with like having the value redundantly, we want to be informed about this. RxJS doesn't, by default, doesn't care about what value is emitted, but it cares about the fact that a value was emitted. So in this case, you would get that one. And that is a very fundamental difference. RxJS doesn't care about the values coming. Signals partially do due to its memorization logic. And this sums up really well when you want to use signals and when you want to use observables. You want to use signals basically every time you want to render something. And for pretty much everything else, I would recommend you using observables. There are some gray areas. I agree with that. But I think what is important is, very often in talks like that, we're talking about the fact that we have this fine-grained reactivity. And I hated that term. I couldn't open X, and read about fine-grained reactivity. The thing, I came to the realization that it is a pretty good differentiation, though. RxJS is coarse-grained, meaning it doesn't have a general purpose. It has a general purpose, whereas signals have a very specific purpose. I should make a talk about coffee and fine-grained and coarse-grained, as we'll see. Perfect. But what I like to think about in this context, I don't think it's an either-or kind of situation. I don't think you're going to see an application in 3-4 years, an Angular application that is just going to have signals or that is just going to have observables. That is not the case. And I would assume you did something wrong if you have that. What I like to think about more of an and kind of thing. You have situations where you want to use signals, usually UI things, you want to render something, and you have situations where you want to use observables, fetching data, aggregating data, those kind of things. It was very theoretical so far. I get that. The thing is to look at it a little bit more on like how an Angular application looks. And on a super high level, every Angular application that I've seen in the last 8-9 years looks like this. You have basically, in the client side, a 3-tier architecture between state, abstraction, and UI. You have some kind of state layer, you fetch something, you get something somewhere. You have some kind of abstraction layer where you might provide general logic, aggregation, those kind of things. And you have components where you render stuff. If we talk now about where you want to use signals in those cases, you want to use, oh, I have a fancy presenter. You want to use signals in those 2 layers. That's pretty much about it. And with state, I mean remote state, fetching state, not like state, remote state. So you want to use signals for everything UI. I would, pretty much in a component, I would expect signals and not observables anymore. And in those abstraction layers where you might aggregate different remote states to provide for your components. That's where you would want to use signals. For observables, we have this absolutely not aggressive pink color here, representing observables. And you want to use those preferably. There are situations where you might gain benefits of using observables on the component layer, in the UI layer. But as a general rule of thumb, I would take that step back and take the observables more in the fetching state layer, aggregating state layer, those kind of things. OK, you see that. Do I have time? I do have some time for live coding. Is the timer for 25 minutes or 20?
25, you're good.
I'm good, easy. OK, so let's do some live coding, because I still was like fairly theoretical. And I did, well, I had it prepared beforehand. Let me open the code real quick. And so what I did is I have an application here that heavily uses internet. Looks great without internet. I should have checked that before. No. Come on. You can do it. You can. Yay! Live coding is great. Awesome. Flawless presentation. Okay, so as you see here, we have a very sophisticated application with plenty of features. As you don't see, we have basically Amazon. So you would, with an internet connection, see some pictures here of products. Sorry. Let's focus more on the coding aspect. Because like those demo doesn't really make much sense. So we have a shopping cart application, heavily inspired by Amazon. So we have technically some features like filtering, sorting, pagination. We do offer like an aggregation of all the items in the cart to collect like the sum and those kind of things. So plenty of features. And this application uses heavily behavior subjects. We can go to our product store or product service. And someone wrote some very good RxJS code here. Not saying I did write it like this and I would do it again, but not saying you should write it like this. But it heavily uses behavior subjects. And once you realize that behavior subjects are pretty similar to signals, pretty similar, you realize how easy it's going to be to refactor some of your codes to be more signally? Pretty sure that's a word. It should be a word now. Angular team for the docs, the adjective for signal is signally. You're welcome. So how I would start with refactoring this. Not saying you should refactor everything. There's strategy to that. But what I would do, the first thing that I would do is use the new input method to signalify those things. I thought I'm on a different, but what I actually wanted to show is, yes, so we have our product service here, and in this get products, we do get, as the name suggests, the signal, the observable, with all the products. Wrong component. That's what I was looking for. So here we have our observable with all products. What I would do now, as a very first step, and I'm not saying this is sophisticated refactoring, but what you can do, and what will improve your code already and get you one step closer to a signal-based component. Signal? Yes. Is use from to observable, to signal. I know this is crazy to just wrap the observable as a signal, but it is a good starting point. I would also remove that dollar because that's more an observable thing. And refactor, rename. And in the template, what we would do, we don't need async pipe anymore, but we unbox it. And we should be good, I guess. Did I do the import right? Do signal, yeah. So I just assume the code works because I cannot test it anyway. That's how you do it. That's how you know you're a senior developer. Your code just works. Luckily, I'm somewhat prepared and do have different commit messages showing each and every refactoring step. So that's pretty much what I did, didn't I? So you unbox the item and you're good. To signal is a good step to transition from your observable-based code to a signal-based code. It sounds easy, and it is that easy. I would actively recommend you to go that step and therefore take out the observable code out of the component. The next step would be to transition that and actually have like your UI state logic in a service to make it more reusable. After like 2 failed attempts, I'm not going to try live coding again, but so what I'm going to do is I'm just jump to the commit and show you what I mean with that. So we have our cart service. And actually, I can show you the before and after. Compare. Compare with Looker. Cart service. Can you read that? Yeah, that's not too bad. So we had a behavior subject before, and we changed that to a signal. And instead of saying subject.as observable some operators, you basically can just use computed, very similar in that context. And instead of saying behavior subject.next, what you do is say signal.set or patch update. And the last step, and we had just a great talk about signal store, would be to actually utilize one state management library, because this is a little bit hand-rolled, and this is fine for like an easy example. But if we think back to the product service that I showed earlier, there was heavy aggregation logic going on. I would highly recommend using something like Signal Store, and I'm a big fan of Signal Store, so I would really recommend that. And let's go back to my slides, where I actually, because I thought I might mess up the live coding, have some pretty code. So just a quick recap, because I still have some time. So instead of saying, hey, I use the async pipe to get some data and render that, how we used to do it for the last couple of years, I would really recommend you using toSignal. That's a very reasonable first step to start that process. The next step, from my perspective, and also here's the importing case. The next step, if we're looking at like how a service with a subject pattern kind of looks, I would start the transition to signals like this. Instead of using new behavior subject, you use a new signal. Instead of operators, you use computed. Instead of emit, you use set, which I have fancy animations for. I was so prepared. The last thing that I want to show, and that is really something that is very important to me, and I teased this somewhere at the very beginning of this talk. This is something that you're going to see in blog posts recommended these days, and not actively recommended, but it's used in blog posts. This is bad. Don't do this. This is a race condition. If you have an async await, a promise then, without an if block around it, it is a race condition. If you don't believe me, I can even write you a test to prove it that it's a race condition. I just need to trigger this async or this effect twice with my city signal, and then it's like, okay, which city am I in now? Because my service or my REST API doesn't necessarily, it definitely does not reply synchronously. So instead of doing something like this, I would use something like ng-extension, which provides a computed async. If you really want to do something like that, you can also use Signal Store. They have methods to do it this way. Async await is fine if you know what you're doing, but there are definitely an equal amount of foot guns than Observable have. Yes, it looks nice and easy. It is not. It's just not. So be a little bit mindful of that. Try to write applications that are at least behaving the way you would expect it. And that is all I got. Thank you very much. Here are my slides and code and stuff.